All right. Now let's see the difference quotient and the limit. Now we are going to start derivative. So these concepts are very important. So this is a transition from finding, the average rate of change and combining with the limit, then it gives us idea of derivative. So I'll start with a graph. The graph is a very important thing to visualize the problem. All right. So assume that this is the graph of, let's say, f of x. Now we start, for example, we start from a and a distance h, then this becomes a plus h, right? If you just walk h distance from a, so the coordinate become a plus h. Now this is at a, f at a, at some distance from a, it is f a plus h. Now the same thing. Now the vertical distance is f of a plus h minus f at a, and the horizontal distance is just h. So remember, average rate of change is f of a plus h minus f at a divided by a plus h minus a, which is finally it becomes f a plus h minus f of a. The bottom one becomes h, right? So this is average rate of change, and now since we just use the distance h, we call this one the difference quotient. So the difference quotient formula is based on some unknown h, so we can just write. Now, what will be the value when the limit of h approaches 0 of the difference quotient a plus h minus f of a over h? Now this is known as derivative. F at given a is defined as this one, and h should be different from 0. Now we are starting derivative. Assume that the concept is, what if the average rate of change when you are getting closer to, or the difference is h is closer to a, or h is close to 0. That means the gap is it's very small, or h is getting closer to 0. So in other words, we call it, this one is instantaneous rate of change, because we are finding the rate at a point. That's why we call it instantaneous rate of change. Let us elaborate this one with an example.